Good afternoon, everyone. I hope I am audible. I would like to welcome you all to the YouTube channel of Chem Academy. Today, we are going to discuss the previous year IIT JAM questions from conductance. Quickly connect everyone, share this video with your friends. If you haven't subscribed to our channel yet, please subscribe to our channel. Like this video and share it with your friends so that they can also get access to quality content. Hello, Gauri. Good afternoon. So let us begin with today's questions. So this is the very first question for today. What does this question say over here? The ionic strength of 0.1 molar aqueous solution of Fe2SO4 whole thrice is. We have to calculate, we have been given an aqueous solution of Fe2SO4 whole thrice, and what do we have to calculate? We have to calculate the ionic strength for this aqueous solution. So let us see how do we do that. First of all, we will write the reaction for Fe2SO4 whole thrice. Then we can go on proceeding on to calculation of the ionic strength. So let me switch the color of the pen. Okay. So Fe2SO4 whole thrice. We know that it is going to break down into twice of Fe plus 3 plus thrice of SO4 2 negative. All right, this is going to be the reaction for Fe2SO4 whole thrice. It is going to break down into twice of Fe3 plus thrice of SO4 2 minus. Now we have been given the ionic strength. We have been given the concentration, that is the solution is of 0.1 molar. All right, it is of 0.1 molar. Therefore, I can write 0.1 over here. But since here the stoichiometry is 2, we are going to multiply the concentration by 2, and thus we will get 0.2. And here, because the stoichiometry is 3, we are going to multiply it by 0.1, and we will get 0.3. Now, we must know the formula for ionic strength. All right, what is the formula for ionic strength? It is represented by I. It will be half of summation of Mi Zi square. Now here M is the concentration, whereas Z will be the charge upon the species. All right, Z represents the charge upon the species, this charge and this charge. Now we are going to substitute the values in this equation for ionic strength, and we can finally calculate the ionic strength. How can we write it as? Mi for 2Fe3 plus, it is going to be 0.2 into, what is its charge? Its charge is 3 and the square of it, plus the concentration for SO4 2 minus, it is 0.3 into, what is its charge? Its charge is -2, and then we will square it. Okay, now upon solving it, we will get 0.2 into 9 plus 0.3 into 4. Now quickly solve it and tell me what should be the final answer. Quickly solve it and tell me what should be the final answer here. Okay. Ayushi says Ayushi says that the answer is D option. Shikha Singh also says D. 5627 Ayushi also says that the answer is D. Raj Gupta says that the answer is D. Let us see. Yes. The final answer is going to come out to be 1.5. All of you are correct. Very good. So this is how we can use this formula and we can calculate the ionic strength. Monu Kumar, there are several playlists on our channel itself which have been made topic wise. You can go there and check out the available topics that have already been taught on YouTube. I'm sure it is going to be very helpful for you. Okay, I hope this question is clear. There shouldn't be any problems. Okay, now moving on to the next question. Now look at this question. This question says, if the transport number of Na positive is 0.463, the transport number of H plus is, we have been given the transport number of Na plus in a dilute solution of NaCl and menthol, and we have to calculate the transport number of H plus in another dilute solution of HCl and methanol. Okay, so now how do we do this question? We know that one very important thing that we, first of all, let us write what we have been given in the question. So over here, we know that the transport number of Na positive has been given as 0.463. This is in the case of NaCl. All right, this is in the case of NaCl. We know that. So if you're talking about NaCl, we will know that the transport number of Na positive plus the transport number of Cl minus, it is going to be equal to 1. All right. Now, if we put the value of transport number of Na in this equation, we will get 0.463 plus transport number of Cl negative is equals to 1. So from here, we can calculate the transport number of Cl negative in NaCl. It will be 1 minus 0.463. Solve it and tell me the answer for the transport number of Cl minus. Solve it and tell me the answer for transport number of Cl minus. What should it be? I also solve these questions along with you people. You also try to solve the complete questions while I do it here. It is really going to help you. So the answer is coming out to be 0.537. All right. Now we have gotten the transport number of Cl. Another important thing that we need to remember is that the transport number of Cl is going to be equal to the limiting molar conductance of Cl divided by the limiting molar conductance of NaCl. Okay, it is going to be the transport number of Cl will be equal to the limiting molar conductance of Cl divided by the limiting molar conductance of NaCl. Now, if we substitute the values over here, how will we do it? We will get 0.537 is equals to, this is what we have to calculate. We have to calculate the molar conductance, limiting molar conductance of Cl negative, and we have been given the limiting molar conductance of NaCl. What is it? It is over here. We have been given it as 96.9. All right, 96.9. So if we calculate the value, we will get the limiting molar conductance of Cl negative as calculated, and please write it in the chat. Calculate and write it in the chat. 0.537 into 96.9. So it will come out to be 52.03. It will come out to be 52.03. All right. Now that we have gotten the limiting molar conductance for Cl, now we know the switch the pens. I think white will be better visible here. We know that the limiting molar conductance of Cl negative is 52.03. Okay. Yes. So this is what we have calculated so far. I hope there shouldn't be any problems regarding this. Now, what do we have to do? We know we have to calculate the transport number of H plus. Before that, we will have to calculate the limiting molar conductance of H plus. Okay. So we know that the limiting molar conductance of HCl is equals to the limiting molar conductance of H plus the limiting molar conductance of Cl minus. Now we will substitute the values here, as we can see that the limiting molar conductance of Cl has been given as 52.03. Limiting molar conductance of H plus is what we have to calculate, and let us put in the value of limiting molar conductance of HCl from here, which is what? 192. Okay, it is 192. So from here, the limiting molar conductance of H plus is going to come out to be 192 minus 52.03. Okay, so on solving it, we will get 139.05. From here, we got the value of limiting molar conductance of H plus. Now, what do we have to finally calculate in this question? We have to calculate the transport number of H plus. Again, we will use this formula that we use in case of Cl minus, but now here we will use it for H plus. So it will be like the transport number of H plus is equals to the limiting molar conductance of H plus divided by the limiting molar conductance of HCl. Now we will put in the values. It will come out to be 139.05 divided by 192. Solve this and tell me what should be the answer. Solve it and tell me what should be the answer. So the final answer over here . No, all of these people, Ayushi, Silly, Raj, Shikha, they're all saying that the answer is 0. Answer is C part, which is incorrect. You need to look at the question again. Look at the method with which I have solved the question. D part is going to be the correct answer. Ayushi Rajput, very good. Yes, D part is the correct answer. Shikha Singh, yes, correct. Raj and Silly, yes. Now you have gotten the correct answer now. D part is going to be the correct answer here. Carefully look at the method, how I have solved it, and that is how this question is going to be done. Okay, so D part is the correct answer. The final answer is 0.73. This is the transport number of H plus. Okay, I hope everyone understood this question very well. Now we will move on to the next question. Lakhan also says that the D part is the correct answer. Yes, very good. This is right. Okay, Raj Gupta. Okay, I got it. You were telling me the answer that I had asked back then. Okay, got it. You are right. Yes, correct. Now, let us look at this next question over here. So, let's see what this question says. the conductance at infinite dilution follows the order. The conductance at infinite dilution follows the order. So we have been given three species, that is Li plus, Na plus, and K plus. So if we have lithium, sodium, so if we have lithium, sodium, and potassium, we know that as we go down the group, the size increases. Okay, the size increases. We know that the size of Li plus is going to be the smallest. The size of Li plus is going to be the smallest. So in case of dilution, when water will be added, what is going to happen? The smaller the size, the more number of water molecules will it attract. Okay, since Li plus will have the smallest size, what is it going to do? It is going to attract the maximum number of water molecules around it. So when so many water molecules come and stick around Li plus, its size from being the smallest size of Li plus, in case of aqueous solution, its size is going to be the biggest. Okay, because so many water molecules come and stick around Li plus, its size is going to become the biggest in comparison to Na plus and K plus. So if I have to talk about without dilution, if you have to compare size when there is no aqueous solution, in that case the size will increase down the group, that is the size of K plus will be biggest, then Na plus, and then Li plus. But when we have an aqueous solution, in case of aqueous solution, the size of Li plus is going to become the biggest. And since we know that size is inversely proportional to conductance. Size is inversely proportional to conductance. From here, since the size of Li plus is going to be the Li plus aqueous, size of Li plus is going to be the biggest, therefore its conductance will become the least. Therefore from here we can say, because the D option will be the correct answer, because the size of Li plus is going to become very huge because of all of the water molecules that are going to come and stick around it. Okay. See, this has been given very clearly over here. You can refer to these slides later. However, I have already explained how this happens. Yes, all of you people are correct. Ayushi, Raj, Silly, Shikha, Tripti, Lakhan. Yes, you're all correct. Yes, Anand, absolutely correct. Rashmi, you need to look at the question again. Try to understand the explanation that I have given. I hope you have understood it by now. D option is going to be the correct answer in this case. Option A is incorrect. I hope this is clear to everyone. Now we will move on to the next question. Anand also says D option. Yes, absolutely correct. Now we will move on to the next question for today. Okay. So here this question says the equivalent conductance of NaCl at concentration C and at infinite dilution are lambda C and lambda infinity respectively. The correct relationship between lambda C and lambda infinity is given as. Okay, we just have to determine which of these is the correct equation. So I will try to explain it to you from the very beginning. At infinite dilution, see, at infinite dilution, lambda C is equals to lambda M infinity. This happens at infinite dilution. All right. But there are two kinds of effects. First is the asymmetric effect, and the second is the electrophoretic effect that occurs in a certain solution. Now, one is what? Asymmetric effect. One is the asymmetric effect, and the other one is the electrophoretic effect. And the other is the electrophoretic effect. Now, because of the asymmetric effect is also known as solute interaction. It is also known as solute interaction, and electrophoretic effect is also known as solute solvent interaction. It is known as solute solvent interaction. So in case of these interactions, what happens is, whenever these kind of interactions, when they operate in a particular solution, what they do is they actually start decreasing the conductance. They start decreasing the molar conductance from its, this is the maximum value. Okay, this is the maximum value, and because of these effects, the molar conductance actually starts decreasing. So because of symmetric effect, the amount that decreases is A lambda m infinity under root C minus B under root C. Now this term is due to asymmetric effect, and this decrease is due to electrophoretic effect. Okay, so because of these interactions, the conductance actually decreases in a particular solution. So now this equation is known as, if I have to talk about this equation, this entire equation is known as 𝗏 equation. 𝗏 equation. Okay, this entire equation is known as what? 𝗏 equation. So in this case, if I simplify this equation, it will become lambda m equals lambda m infinity. If I simplify that equation, then I will get B into under root C, where C is the concentration. Now on simplifying that earlier equation, this is what we will get. And over here, this B is actually called Roush constant. This is actually what? Called Roush constant, and this is the simplified version of the 𝗏 equation. Okay, so from this, what can we say? We can say that the correct answer over here is going to be the C part. Okay, C part is going to be the correct answer. See here, this is the Roush constant. Okay, this is the Roush constant. I hope this is clear to everyone. Yes, Ayushi, Raj, very good. That was the 𝗏 equation. You're absolutely correct. I'm sure this question is clear to everyone. Now I will move on to the next question. If you haven't subscribed to our channel yet, first you quickly subscribe to this channel, like this video, subscribe to the channel, only then I will move on to the next question for today. Jaldi, fast. Quickly subscribe to the channel, like this video, and then we will move on to the next question for today. I am here solving these questions with you. I'm sure this is going to be very helpful to all of you. The least you can do is like this video and subscribe this channel. Okay. Thank you, everyone. And now we will move on to the next question for today. Let's see. Now this question says that the resistance of a 0.2 molar solution of an electrolyte is 50 ohm. the specific conductance of the solution of 0.5 molar solution of same electrolyte is 1.5 Simon meter inverse, and resistance of same solution of the same electrolyte is 280 ohm. The molar conductivity of 0.5 molar solution of the electrolyte in Simon meter square mole inverse is. Okay, so we have been given 0.2 molar solution. We have been given the resistance. Now we have been given another solution of 0.5 molar. We have been given its resistance. We have been given kappa. This is the specific conductance, or kappa, represented by kappa. Okay, and what do we have to calculate? The molar conductivity of 0.5 molar solution of electrolyte in Simon meter square mole inverse. Now let us see how will we do this question. So we know that R is equals to rho into L upon A. Okay. Now R is the resistance. We know that R is the resistance. Rho is specific resistance, and this term length is the separation between electrodes, and L represents what? The separation between the electrodes, and A represents the area of electrodes. This entire term, now L by A can be replaced by X. Okay, this is called the cell constant. Okay, this remains, now cell constant remains same for a reaction. Okay, thus a cell constant does not change in case of a reaction, in case of a particular cell. Okay, so now what also we need to know, we must remember that rho is equals to 1 upon kappa. Kappa is what? Kappa is specific conductance or conductivity. This is specific resistance, rho, and this is K, specific conductance. So I can write it as R equals 1 upon K into L upon A, or further simplifying, I can write it as R equals X upon K. Okay, now we know that we have been given the value of kappa as 1.4 Simon meter inverse. Okay, I will convert it to centimeter for easy calculation. So I'm going to write it as kappa equals 1 upon 4 divided by 100. So it will become Simon centimeter inverse. Now what did we get? We had derived the formula. K equals X upon R. Okay, we are going to substitute the value of K here, which is 1 upon 4 into 100 is equals to, we have to calculate the cell constant from here, and what was the value? What was the value for R here? The first value of R was 50. Okay, quickly solve it and tell me the value for X here. What would be the value of X? I am also solving with you people. Quickly tell me the value for X. Okay, so from here you get the value of X as 0.7. Okay, this is the cell constant. We know that this is the cell constant. Now that we have calculated the value of cell constant, let us see what else we have to do. Now we have to calculate the specific conductance of the solution. Okay, we have to calculate the molar conductivity of 0.5 molar solution. Now that we have calculated the value of cell constant, now we will calculate the kappa for a 0.5 molar solution. So how will we do that? How will we do that? Again, we will use the same formula, K equals X upon R. We know that the value of X is 0.7, but this time we will take the resistance for the 0.5 molar solution, which is 280. So what is this new kappa going to be? The value for this new K is going to be 0.7 divided by 280 is going to be 2.5 into 10 raised to the power minus 3. Okay, this is the new value of K. Now, what did we have to finally calculate? We had to calculate the molar conductivity. So what is the formula for molar conductivity? We know that the formula for molar conductivity is lambda m equals K into 1000 divided by molarity. Now, on putting in the values, we will get 2.5 into 10 raised to the power minus 3. Okay, into 1000 divided by, what was the concentration? The concentration here was 0.5. Quickly solve this and tell me the value for molar conductivity. What should be the value for lambda m? What should be the value for lambda m here? So this is the final answer that is going to come out, and the unit will be, if we solve it in meter, it is going to be Simon meter square mole inverse. Okay, this is going to be the final answer here. So Raj and Ayushi, the answer is coming out to be 5. See here, this is the answer. This is coming out to be 5 because here it is in centimeter square. Okay, this is in centimeter square. You remember earlier we had converted it into centimeter. Okay, now this is the answer, but we will have to change it in the form it has been given in the options, right? So we will convert the centimeter square. What will we do? We will convert this centimeter square into meter square. That is why this 10 raised to the power minus 4 is coming. Okay. Answer will come out to be 5, but you will have to be very careful about the units also, na? Here the units are Simon centimeter square mole inverse. Here the unit, but here the unit is Simon meter square mole inverse. I hope it is clear. There should not be any problems in this. So we know that the final answer here is A1. Ayushi Rajput, yes, these PDFs will be made available to you. You will be able to download these PDFs later. Okay, no problems with that. I hope this is clear to everyone. Now we will move on to the next question for today. Okay, so let's see what this question says. This question says that plot schematically the concentration dependence of molar conductivity of a strong electrolyte and a weak electrolyte in the same figure. So first of all, if we have to plot a curve, let's see how we do that. Then we are going to proceed to the next part of the question. So over here, if I have to plot a curve, what will it look like? It will be lambda m versus under root of C. C is the concentration. This is the molar conductance. So if I have to plot a curve, it is going to be like this. This is for a strong electrolyte. This is for a strong electrolyte. And if I plot it like this, this is going to be for a weak electrolyte. This is for a weak electrolyte. Now, moving to the next part, it says that the limiting ionic molar conductivities of K plus and Cl minus are these. This is for K plus and this is for Cl minus respectively. Respectively means first one for K plus and the second one for Cl minus. It says if the molar conductivity of 0.1 molar KCl solution is 130 Simon centimeter square mole inverse, calculate the Chloroacetic constant for the KCl solution. So first of all, let's write down the information that we have been given. They say that the molar conductivity, that is lambda m of KCl, is equals to 130 Simon centimeter square mole inverse. Okay, and we know that the limiting molar conductivity for K plus is 73.5 and that for Cl minus is 76.5. So if I have to calculate the limiting molar conductivity for KCl, it can be done as limiting molar conductivity of K plus the limiting molar conductivity of Cl minus. Now if I add these, I will get 73.5 plus 76.5. It will come out to be 150. Now this is the limiting molar conductivity of KCl. Okay, this is the limiting molar conductivity. So what do we have now? We know that the formula from 𝐴𝐶 equation, we know that the formula is lambda m equals lambda m infinity minus of b under root c. We have already done this in the previous question. I have explained you where this equation comes from, and we know that the value for lambda m, it has been given as 130 equals lambda m infinity. We have just calculated. It came out to be 150. We have to calculate small b, that is the Chloroacetic constant. And what was the concentration? Let us go back and look at the concentration. It was 0.1 molar of KCl. So the concentration is going to be 0.1. Now if I solve it, it is going to be b under root of 0.1 equals 150 minus of 130. So it will come out to be b equals 20 upon under root 0.1. Quickly solve it and tell me what should be the answer. Tell me the value for b. What should be the value for b here? Solve it and tell me the answer. Solve for the value of b and write it in the comments. Quickly solve and write the answer. Ayushi says that the answer is going to be approximately 63.29. Okay, Silly also says 63.2. Ayushi, Rajput also, Raj 63. Okay. Yes. The final answer is coming out to be 63.29. All of you have solved it absolutely correctly. So the final answer for B is coming out to be 63.29. Very good. I hope you all have understood this question very, very clearly. Okay. I'm sure this is clear. Now we will move on to the next question for today. See, what does this question say? The molar conductance of 0.01 mole dm cube inverse aqueous solution of chloroacetic acid is 100. The ionic conductance of chloroacetate and H plus ions are 50 and 350 respectively. We have to calculate the degree of dissociation and pKa of chloroacetic acid, and we have to calculate the H plus ion concentration of the solution. Let's see how to do this question. So, what do we have here? What have we been given in the question? They have given us over here the molar conductance. All right, we have been given the molar conductance as 100, and we have to calculate the limiting molar conductance of the chloroacetic acid, and we have been given these values for H plus and chloroacetate ions. So we will just simply add it, 50 plus 350, and the value is going to come out to be 400. The units are important. It is going to be ohm inverse, centimeter square, mole inverse. Similarly here, ohm inverse, centimeter square, mole inverse. So from here, first of all, what do we have to calculate? We have to calculate the degree of dissociation. The degree of dissociation is represented by alpha. So what is the formula for degree of dissociation? What is the formula for degree of Ayushi says that the question is not completely visible. Is that so? Can you not see the complete question here? Or is the question completely visible? I don't think there has to be any problems in the question. Okay, so the degree of dissociation can be written as, lambda m divided by lambda m infinity. Now if I put in the values, it will come out to be 100 divided by 400. So actually it will be 1/4 or 0.25. So that is how we have calculated the first part, that the degree of dissociation. Now we have to calculate the pKa of chloroacetic acid. So how will we do that? So first of all, we will have to write the reaction for it. Okay, we will have to write the reaction for it. So the reaction will be HX. It gives H plus plus X minus. Okay, this is how we will write the reaction for it. Now, suppose its initial concentration was C. So after some time, it is going to become C minus C alpha. Okay, and initially there was no H plus or X minus. So what will be the amount of H formed? It will be C alpha, and the amount of X minus formed will also be C alpha. Okay, it will also be C alpha. Now, if I have to write the dissociation constant, it can be written as C alpha into, let us represent it with a dot, it will be clear for you. It will be C alpha into C alpha divided by C minus C alpha. Where did this come from? Actually, okay, This will be the concentration of H plus into the concentration of X minus divided by the concentration of Hx at time t. So this is actually C square alpha square divided by, we will take out C to be common, it will come out to be C into 1 minus alpha. This C will get cancelled out, so we will get K equals C alpha square upon 1 minus alpha. Alright. Now putting in the values in the equation for Ka equals, what was the concentration? Let us go back and see the concentration. It was 0.012. We know that the value for alpha was 0.25 whole square divided by 1 minus 0.25. Solve it and tell me the value for Ka. Quickly solve it and tell me the value for Ka. What will be the value for Ka from here? Solve and tell me. Solve the value and write it in the comments. Let's see what is going to come out to be the value. The value will from here will come out to be 10 raised to the power minus 3. Okay. So the value will come out to be 10 raised to the power minus 3. This is the value for K. But in the question we have been asked to calculate the value for pKa. Wherever there comes P, you should remember that it actually means minus log. It means minus log of Ka. Now if I put in the value, it will actually become minus log 10 raised to the power minus 3. Solving this minus 3 will come ahead. It will become 3 log 10, and we know that the value of log 10 is 1. So the value of pKa will come out to be 3. Okay. The value of pK will come out to be 3. Ayushi Rajput, the value of pKa will not be 10 raised to the power minus 3. Actually, the value of Ka will be 10 raised to the power minus 3. Then when we will take minus of log with it, from there we can calculate the value of pKa, and that will become 3. Yes, Ayushi Rajput, now you got it correctly. Silly Pradhan, 3. Yes, correct. Now what else do we have to calculate? Let us see from the question. We have to calculate H plus ion concentration in the solution. See, here the H plus ion is actually being represented by C alpha. Okay. So actually the H plus ion concentration we will get from C alpha. What was the value of C? The value of C was 0.012 into what was the value for alpha into 0.25. You solve it and tell me what should be the answer. Solve it and tell me the answer. From here, the answer is going to come out to be 3 into 10 raised to the power minus 3. This will come out to be the answer for H plus concentration. Okay, they have written it like this. 0.003. You can also solve and write it like 3 into 10 raised to the power minus 3. I hope this is clear to everyone. There should not be any confusions. Okay, this is how we solve this entire question. Now, moving on to the next question for today. Okay, This question says that the molar conductance at infinite dilution for BaCl2, KCl, K2SO4 and Cl minus are 280, 150, 300 and 76 ohm inverse, meter square, mole inverse respectively. We have to calculate the transport number of Ba2 plus in BaSO4 at infinite dilution. So we will begin by writing down the individual equations for molar conductance of each of these. So how do we do that? We know that the lambda and infinity of BaCl2 is equals to lambda infinity of Ba plus 2 plus lambda infinity twice of Cl minus, since it is Cl2, it is equals to what? 280. We know that lambda in infinity of KCl is actually equals to lambda infinity of K plus lambda infinity of Cl minus. Its value is given as 150. Next we have K2SO4. So lambda infinity of K2SO4 is going to be lambda twice of lambda infinity of K plus lambda infinity of SO4 minus 2, which has been given to be 300. Okay. Now we have to calculate for BaSO4. So in case of BaSO4, we can write it as lambda infinity of Ba plus 2 plus lambda infinity of SO4 minus 2. This is we have to what? Calculate. So to get for this, we will have to add or subtract these equations. So what will we have to do here? We need Ba and SO4. We will get that from equation 1 and equation 2. But we will also get K plus and Cl minus extra. So we will subtract twice of equation 2. Let's see, what am I talking about? So for BaSO4, actually, for BaSO4, we will take equation 1 plus equation 3 it was, right? It was equation 3 minus of twice of equation 2. Okay. Equation 1 for Ba, equation 3 we will add for SO4, and we will subtract twice of equation 2 to get rid of the K plus and Cl, because that is not required in BaSO4. So we will have 280, okay, plus 300 minus of twice of, what was the value for the second equation? It was 150. It was 150, okay. It was 150. So from here, what will be the final that we will get? We will get 280. All right. We can easily know that lambda n infinity of BaSO4, it is coming out to be 280. Okay. Now, what we have been asked in the question? What have we been asked in the question? They have asked us to calculate the transport number of Ba plus 2 in BaSO4 at infinite dilution. We have to calculate the transport number. So we know that the transport number of Ba plus 2, it will have the formula lambda n infinity of Ba plus 2 divided by lambda infinity of BaSO4. Now, we know that the value, see here, we have been given the value of lambda n infinity of Cl minus, which is 76. What do we know that? We know that the lambda n infinity of Cl minus is actually 76. So from this and this, we will calculate for BaSO4, sorry, for Ba2 positive. So we know that lambda m infinity BA4 is equals to lambda m infinity of BA plus 2 plus lambda infinity of C or minus. Sorry. Oh, we have to calculate for this BaCl2 actually. So not for BaSO4, we have to calculate for BaCl2. Now the question has become even more easier. This makes the question actually in fact more easier. Okay, we have to calculate for BaCl2. This is in fact easier than BaSO4 because see over here we had already been given the value of lambda m infinity Cl minus in the question. We will just simply write the breakup of the equation. We will put in the values. Okay, we will put in the values. We know that the value for BaCl2 was 280 plus we have to calculate this lambda m infinity of Ba plus 2, and from this we will put the value 2 into 76. When we will solve it, we will get the value of lambda m infinity of Ba2 positive. Then we will put it again in this equation, and from here we can calculate the transport number of Ba plus 2. I hope you got it. Okay. There was some confusion. We did not have to calculate it with respect to BaSO4, but we had to calculate it with respect to BaCl2. Now finally putting in all the values. Okay, we put this value here, and BaSO4 we had already calculated, and from here we have calculated the transport number of Ba plus 2, which is coming out to be 0.457. Okay, now moving on to this is the last question that we will do today. This is the last question for today. Okay. All of you who have answered, Ayushi, the answer is correct. Ayushi Sen, Ayushi Rajput, Raj Gupta, you have, I think, rounded off the answer. That is also correct. Now, here, look at this final question. The electrolyte AB ionizes in water as this. Okay. The mean ionic activity coefficient gamma plus minus is. Now, this question can be solved with the help of actually a very simple formula. Okay. That formula that you need, which you will have to remember, and through that you can solve all of these questions of such type. So the formula is gamma plus raised to the power x, gamma negative raised to the power y, and the power of whole of this would be 1 upon x plus y. This is the equation that you need to remember. This is the formula that you need to remember, and you will be able to easily solve all the questions of this type. Now here x and y are the stoichiometries of the product species. X is the stoichiometry of A and y is the stoichiometry of B. So if I put in the values now, then gamma plus raised to the power will be 1, gamma negative will be raised to the power 2, and the whole power will be 1 upon 1 plus 2. So if I open up the brackets, it will become gamma positive raised to the power 1 upon 3 and gamma negative raised to the power 2 upon 3. Okay, from this we can see that the correct answer is D. This is the answer. You can just simply use this formula and all of these questions can be solved very easily. I hope this is clear. STS DDT, the option C option is not correct. You are wrong. Please look at the explanation that I have just given. I think you will be able to understand. Yes, now I think you got it. It is correct. I hope it is clear to everyone. Okay. This is some error in this. I hope it is clear to everyone. Please subscribe to our channel. Hit that bell icon, like today's video and share it with your friends so everyone can get access to quality content. I hope you all liked today's video and enjoyed today's session. We will keep on doing such questions every week. So stay tuned with Chem Academy. Ayushi Rajput says, ma'am, numerical section answer. Ayushi, no. The answer will still be correct because generally whenever there is a decimal, we consider only the answers up to 2 decimal places. Okay, and this is 8.003, so it is almost nearly equal to 8. So you can write it either ways and it is not going to be correct. Ayushi Rajput, yes. If you have a multiple select question and there are 3 options correct, but if you will take only 2 of them, even then your question is going to be incorrect. In MSQ kind of questions, all of the correct answers must be ticked, and even if you incorrectly tick one of the options, then the entire question becomes wrong. Ayushi Rajput, sometimes the answers could be wrong, but that doesn't mean that your approach is incorrect. I'm telling you that 8 and 8.003 both are going to be correct. There is no problem with that. You can rest assured. When you will give the actual exam, this is not going to be a problem. So you can be assured about that. Ayushi Sen, today the time for the class is over. I will try to solve questions based on Faraday's law in the future. Raj Gupta, what are you talking about? K equals C alpha square use कर सकते हैं direct. In which question are you talking about? If any of you have any queries, you can write down later. Even after the class gets over, you can write down those questions in the comments and I will try to answer them later on. You don't have to worry about it. If you have any queries or any questions, you can write them down in the comments and those will be resolved later. Okay, so with that, we come to an end for today's lecture. Thank you all of you for joining. Please keep watching, keep sharing our videos. You can subscribe to our channel if you haven't done that already. Click on the bell icon to keep getting notified whenever we upload a new video. Thank you so much for joining. With that, I will end today's session.